Alright guys, we're back. Here we are in my garage again. Wait for the camera to focus. Blurry vision, just woke up. Hey guys, this is week 2 of engine performance. This is what I've been up to the last couple of days. This transmission is out. So today we're going to talk about ignition and induction, which is air. I need to get this pressure plate off next. Where's the transmission? It's on the floor. So this is how you do it at home. And again, practice what you preach. Check out my nuts and bolts, nice and clean. And then all the tools that I use that will need to be cleaned, bam, right there. So you guys are going to want to print out my worksheet again, just like last week. If we go to CDX, Engine Performance, Launch, up here announcements, week 2 lecture, and then right here, my worksheet. So pause the video here and go print it out. That way you have it in front of you. You can follow along with me. Also, I had a couple people, I said, do you have any questions for me? And they would say, yeah, I do, but I don't remember them. So before you go much further, go get something to write on and something to write with. That way when I talk to you on Friday, you can reference your questions. So that way we're all on the same page. So I normally like to start off with this little video. This is an F1 engine. Look at that raw fuel just being sprayed in there. And I'd say that exhaust is a little hot, wouldn't you? So those things rev to 22,000 RPM, and I don't know if you saw during that, but it was up to 18,000, which is insane. So here, the page 1 of the worksheet, we've got another pretest. I'm gonna let you guys work through that. The answers are at the end. This should be stuff that you should have either covered in CDX by now or from last week. And this very first module, engine performance, I did a little differently from the rest of them, so I'm going to jump around a little bit. Let's start with talking about ignition, and we're going to go over the evolution of ignition. So in the beginning we had a distributor. In the classroom I have one I like to show, so you just have to deal with this picture here. And in a distributor wasn't a bad idea. The way that it worked basically was we would supply 12 volts from the battery to a coil that lived inside this guy or very near it. As these got more advanced, we started putting the coil inside of them. In the beginning, the coil lived outside of them. Either way, a coil, no matter when and where we say the word coil, it always means we're going to take a small amount of voltage and increase it. So why do we need to increase the voltage? You've all seen a spark plug, and this is the part where I pass one around in class, but we're not in class. So you know what a spark plug looks like. And let's get a good image here. Of course, I would pick one that's sideways. Here we go. So the reason we need super high voltage, let me zoom in right here, you bastards. Right here, from the tip of the electrode to this metal here, we have to get electricity to conduct, and air is not a good conductor. So we are going to create a small lightning, basically. And it takes a lot of voltage to push the electricity through the air. I told you guys in safety and foundations that 12 volts, like the 12 volt battery in the car, won't even push through your skin. So you can imagine 12, 20, 30 volts is not nearly enough to conduct through the atmosphere. So in general, we tell people a coil ramps up to, in an automotive sense, so with what we do on the car, the coil increases the voltage to about 500 volts, which means if you touch it, it will hurt you. So when working with these guys, you need to be careful. So send 12 volts into this guy, and he's gonna ramp up the amount of voltage. And then in the center here, if you look at the bottom, we have some splines, which means this guy is going to spline into something and rotate. So we need each cylinder to get spark exactly when it hits top dead center, right? And the way that we know when that cylinder is on top dead center is this gear right here would mesh with the camshaft. And in that way, no matter what RPM the engine was doing, if it was idling at 800 or revving out at 5,000 RPM, this guy was spinning and was always in time. So our ignition was always in time with whatever the engine was doing. So not bad, it's mechanical, right? If you come up the center of this distributor here, we call this part the rotor, and this is what really spins. And as this guy spins, we're going to pass electricity from the rotor to this cap here. So let me pull up a picture of rotor and cap. I'd show you guys. I don't have a car in the neighborhood that has this technology. This is so old. So like for the rest of it, we'll go outside and look. But for this, there's just none. I don't have one. So here's the inside of one. So here's a good picture. This rotor right here is on top of that shaft that spins, and then it sits inside this cap. So on this diagram here, that's never gonna load. You bastard. Anyway, there's a sideways one. So the point here being that this sucks. So if you put the shaft, the rotor and shaft down into the camshaft in the wrong position, it will be out of time. And looking at how many splines there are on this could go in 6 or 7 different ways. And then the cap gets buttoned down on top, and if it's not correct, then you won't have spark when you want it to. So setting one of these guys up is a pain. If you work on something that has one of these, go ahead and mark everything before you take it out, and that'll really help you going back. Otherwise, you will have to go read the book and find out, put which cylinder where, and then look for this mark and do that and do the other. One of the things about a distributor that is dangerous is that these spark plug wires that leave the distributor and go to the spark plugs on the engine are high voltage. So now we have, like in this V8 here, we have 8 super high voltage wires, and they're gonna go all over the metal. You know, back in the day, this would be a cast engine, and the frame is obviously metal. So the potential for it to ground somewhere with that super high voltage is very, very high. And also, you don't want to touch one of these. So let's, in the beginning, we're doing vocabulary here, so I'm just going to kind of note on each one. And then here's a modern ignition coil. You guys know what this one looks like. This is the one we have in the classroom. And then here's one on the side. Spark plugs, you guys know about the spark plug. Make sure that the ceramic is never cracked, and if you have to gap one, but we'll talk about that in a moment. Here's your spark plug gap tool, if you can still even do that. Technical bits. Now, you're more than welcome to read about this. This is such old technology, I'm not really going to. Here's a very good drawing of how it used to work, right? So from the battery here, we would go to the ignition switch, turn the ignition switch on, and that would supply some voltage to the ignition coil. Like I told you, ignition coil would ramp up, go into the distributor. We have points, that's the inside of the cap, and then the distributor cam is what I was calling the rotor here. And he spins around in a circle like this, spinning and spinning and spinning. And when it hits each part on the cap, it will send that voltage out to my spark plugs. Back in the day, so if you talk to an older mechanic that used to work on, muscle cars, he probably still remembers the firing order, he or she remembers the firing order for like a Chevrolet V8, because it was important. You had to know, because they didn't go in order, right? So you wouldn't take spark plugs and go, oh, from the cap they go 1, 2, 3, 4. No, the engine doesn't fire that way. The engine fires something like, and don't quote me on this, but something like 2, 7, 5, 4, 3, 6, 1, 8, right? Something to spread them around. And if you don't put those on right, then you end up with problems as well. Then, this was our first technology, right? So distributor, this worked okay. And then we moved to a coil pack, and in this schematic we see the introduction of a sensor ring. So position sensor. This one is crankshaft position, camshaft over here. Some engines use both. Some engines use one or the other. Either way, so instead of being, this distributor is splined to the camshaft to tell us where we are in our rotation or what RPM we're doing. We're going to use a sensor mounted to monitor the camshaft or the crankshaft. So we still use this technology. We would send that information to an ignition coil here, and this is a coil pack is what we call this. So this is 3 coil packs. If you get into like late 90s, early thousands GM product, they loved using these big ignition coils. And if anybody's ever had to work on a North Star V8, that's like the dumbest half step in between the old and the new. So this ignition coil is a little bit better because we're not limited by RPM in the way that we were with distributor, and we'll talk about that in a moment. And but the problem here is we still have these hot spark plug wires. Here we have the introduction of engine control. So he's making decisions instead of it being all mechanical, which can be a good thing. We can advance or retard ignition timing with a computer on the fly while the engine's running. Whereas if you were going to try to do that in this system, and that's what some people would do, is advance the ignition timing a little with the cap, which made more horsepower under wide open throttle, but it made it idle rough. And that was, you had to get out and adjust it. So every time you wanted to change, you had to do that. Whereas now, with the computer doing it, we can have a nice smooth idle, and then when we're under wide open throttle, we can have the engine make adjustments. And we've gone from that, I guess I don't have a picture, to the modern coil, which I've got some outside. So let me switch, and I've got some clips of, I've got a few engines open outside. Alright, so on that Mazda, I'm taking the transmission out. Here we see the coils on top, and they're going to be simply computer controlled with spark plug. And then here are our injectors too. Since we're going to be talking about fuel today, I thought I would point them out. So they're on a common rail, which I'm going to try to grab here. And then anytime we have a common rail, the fuel line will be right here. And you see that Mazda gave us a quick disconnect right here. Thank you, Mazda. That makes life. So one of those would be sending and one is return. Don't mind the cat under this Miata. So this one has a coil pack. Check this out. On the back of the engine, we have that computer controlled coil pack. And I was trying to grab the connectors here to show you that there's a big old fat primitive. This is like a 97 model. Anyway, but we still have these hot spark plugs. And so if the engine was running, those would be under super high voltage. And then, let's see, what was I doing here? Oh, here we go. And wife's Highlander. This is a V6, so here's the 3 on the front. And then you can sort of see the number 2 over there. On this engine, you gotta pull the intake to get the back ones. And then I tried to show you on the Subaru. This is a flat 4. It's an opposed engine. So I don't know if the camera, if you can see down in here. I'm gonna try to stick my hand in there. Spark plug, the coils and the direct injection stuff is down there, which means you gotta take the engine mounts out to get to it. Woo! Okay, I found this cool video of spark plugs firing, and I want you to see it and I want you to listen to it, so I'm gonna shut up and hit play. So it's some bright blue lightning, and it makes noise. It makes thunder. So if you wanted to verify you had spark, there's no reason you couldn't take a spark plug out, flip it upside down, put it back in the coil, hold it with some pliers with an insulated grip, and see it. And hear it, everybody. Like, yeah, you can hear spark plugs. You're like, what, really? Like, yeah, dude, I'll show it to you. Or I guess I'll let you hear it, rather. That makes better sense. So check this out. This is a video I found on YouTube of a coil pack, because again I don't have one outside to show you outside of that Miata, which wasn't an example that I liked. So this one has got them all where you can see them, and you'll note that there's two spark plug wires leaving each coil. So what happens is this one fires, and both 3 and 6 both fire. Only one of them is probably on on the stroke where it actually needs the power, if that makes sense. So one of them is firing in the middle of top dead center when there's nothing in the cylinder. Does it hurt anything? Not at all. There's nothing in the cylinder. We call that a dummy spark. There's a lot of systems. Toyota did this for years, where they would have 3 coils on a V6, and it just sparked two of them. One of them got used, and the other one didn't, until the engine rotated 180 degrees, and then the next one, or 360 degrees, and then the next one would use it. So, interesting little bit of strange history where we were not quite the modern like what we had on the Highlander, but this sort of thing here. What really sucks about this, though, is that a lot of times they want you to buy the whole assembly, all 3 of these, because there's a board on the bottom of it. You can see the connector here, and so that made it very expensive. Whereas if we needed one coil, so if we go out here to my Highlander, we need one coil, we just get one. We need one spark plug on any engine, you just get one spark plug. But this coil pack thing was, it wasn't great. I'm glad we got away from it. So how about this grooviness right here? I found a clear distributor cap. So looking at it from the side, this would be the main shaft of the distributor. This is the rotor, is what I call this. It touches these points. Here's one, here's one, here's one. That go up to the leads and then go down to your spark plug. So let's see. He's going to turn this engine over. You can see it spin inside. Check that out. Oh look, you can see the spark. Look at the little blue. Look at that. That is cool. Yeah! Oh, that's awesome. Alright. Good job, YouTube. So, the problem with this is, I told you we were going to talk about that. This is severely limits your RPM, because this guy only spins so fast. Oh, I'm sorry. As this guy is spinning, the faster I spin, the less time I have for each one of, bring the light back, the less time I have for the rotor to give spark, or for it to jump from the rotor to the cap. So you get to 5 or 6,000 RPM, and it's just spinning faster. Oops, phone going off. Is going faster than what I have enough time for. So this is one of the reasons, and carburetor is the other one, and we're going to talk about that today as well. That if we go to look at an old muscle car, the RPM wouldn't do more than 5 or 6,000 RPM. Whereas now, if we go out in the parking lot, every Honda does 9,000 RPM from the factory. All the Toyotas do 8. The Hyundais do 8.5. My motorcycle does 16,000. And it's because we've advanced the ignition and the induction and the fuel delivery. So distributors are simple, and a lot of people still like them. However, they just cannot compete with modern technology. Also, for the reasons of you could mess this all up. If you put the cap on wrong, it's not gonna fire. If you get one of these wires confused with another one, so your firing order's not right, it might not fire. Whereas what we have now with the coil on each cylinder, it doesn't matter where the coils go, because the computer tells them when to fire. And then the harness that goes to those coils, you'd be hard pressed to swap those up. Like, the harness is exactly cut the exact right length that it would be very difficult for you to swap them. So, old technology, get out of here. Alright, so I'm going to jump around in the worksheet here a little bit, guys. I skipped variable valve timing. We will come back to that. That's some high level stuff. We went over spark. Let's go over fuel next. So when we talk about fuel, this could be induction. Sometimes people refer to the intake as induction. I think I got this from CDX. The idea back in the day was we were going to mix air and fuel before we got to the cylinders. That's what a carburetor does. But now we have these injectors that spray fuel directly into the intake, Or for example, my Subaru outside has direct injection, and where you guys work, a lot of the modern vehicles are moving to direct injection, and that means I'm spraying fuel directly in the combustion chamber. So that's in the head next to the spark plug, which is cool. But in any fuel system, we know we gotta have a fuel tank or a fuel cell. So here's the tank on the bottom of your car. Uh, we're gonna talk about PCV today, but next week we're going to talk about exhaust and emissions. And when we talk about emissions, we are going to talk about the evaporative emission system, and that's a lot of this fuel tank stuff. And it's not very interesting. However, that's where you're going to make all your money. All the check engine lights are for emissions. But cheer up, Buttercup. Next week, we're going to talk about forced induction, which is turbos and superchargers, and that's my favorite lecture. So, in addition to having somewhere to store fuel, we need a way to get it to the engine. On our modern vehicle, we have an electronic fuel pump. So on the left here, we have a sending unit. On the right is an example of an old mechanical fuel pump. So let's talk about that for a minute. When we had a carburetor, we didn't need the fuel to be under very much pressure. If you a very simple idea of how a carburetor works is if I gave you a soda bottle, okay, and we stuck a straw in it, yeah, you follow me? And then I took an air hose, so where's my little drawing pad here? So let's go. I'm a soda bottle. Draw, darn it. Okay, I'm a soda bottle. Boop. Boop. You stick a straw in it like this. Ta-da, like that. Now the straw must be submerged in some liquid, right? So imagine the liquid is up here. Boop. And then I took an air hose and I blew air across it this way. So, 80, 100 psi of air moving very quickly across the top of it. It would pull a small amount of fuel or soda with it, and now you would get air and soda. Or this is a very, very simple explanation of a carburetor, air and fuel. So in the bottom of a carburetor, we have a bucket that we call the bowl, and it's a bowl that holds fuel. Ta-da! So in order to get fuel into this engine, in this example with a carburetor, we don't need very much fuel pressure. So to get, I'm the tank all the way at the back of the car. Boop. I just need 8, 10 psi of pressure to get it to move up to the front of the car, right? So not super high pressure. So we could get away with this mechanical fuel pump on the right. You will probably never see one in your life. I've never worked on a vehicle with one of these. It's interesting. This pump lever. Have you guys ever seen maybe it'd be a picture of an old country well, and they've got somebody out there in a straw hat, and he's pumping this lever to get water up to the well, and that's kind of this exact same idea. So the pump lever goes on the camshaft or the crankshaft. If I remember, it was the crankshaft. I saw one once. Anyway, didn't work on it. Saw one. And so something rotating is going to pump it so it comes on when the engine's on, which is pretty simple. So just thought I'd show you. On the left here, this is what we're going to get all the time. So this is a sending unit, and I say that on purpose. Right here, this float lever, so that tells us how much fuel is in this tank. On the bottom, we have a sock. So I want you to think about the last time you put a fuel filter in anything. Nothing new, nothing recent, right? We don't really do fuel filters anymore. So there's a sock or a screen on the bottom of this fuel pump. This is the actual pump, this little guy right here. So the whole thing together is called a sending unit, and I'd like to point this out because in your vehicle, if the fuel pump dies, and you go to Honda and you say, hey, I want a fuel pump, they say, well, we don't sell just the pump. We sell the sending unit. And you go, okay, what does it cost? $300. Oh, I just need the pump. So what you can do, I learned this from an older tech on my CBR 600RR, 2005 model. Honda wanted, and that's a motorcycle, right? So Honda wanted $180 for the sending unit. We pulled the sending unit out, pulled the fuel line off of it, pulled the electrical connector off of it, and there was I think one screw in it. Pulled that out, and then we could see the motor itself. We took the part number off of the motor and went to eBay, and it turns out that Honda's been using that same motor in Civics and CRXs since the dawn of time. So we found a cheap knockoff one for $18, put it in, it worked great for another 3 years. So not that you need to buy a cheap Chinese one. But if you just need the pump, you can take it apart and find the part number on it. So I'd like to point that out. Here we have the bane of my existence. I absolutely hate carburetors. The one on the left is a very simple one, something like you would see on a four-wheeler, dirt bike, maybe a lawnmower. The one on the right is the most advanced one I could find, a Holley 4-barrel. The one on the left is no big deal, and we have one in the shop. I'm going to make you take it apart, and I think it's important because you should be able to fix your lawnmower. And then right now it's April, and as we go for a walk or go get the mail this afternoon, you know we're going to pass a weed eater, a lawnmower, and a chainsaw all by the side of the road. And you go, hey, can I have this? And they go, no, you don't want that, it doesn't run. Well, for about $3 worth of carburetor cleaner, it's gonna run because they all fail for the same reason, which I'm gonna explain in this video. But I kind of want to show you hands-on in the classroom. So remind me when we get back in the classroom that this is a skill you guys should have. It's really simple. This one on the right, though, I'm not touching it. I'm just not. It's got a million little itty bitty pieces, and you suck. We've moved from the carburetors to a fuel rail and injectors. So this is what you guys all know and love, common fuel rail. I need a common fuel rail, and that's what we call it, because at this section here, it needs to be under very high pressure so that when any one of these injectors opens, there's a steady stream of high pressure gasoline available. So there's nothing mechanical about the rail itself. You'll never have a rail fail. Each injector, though, can fail. They're electrical components, so we'll address that separately. And I like to do this on purpose. Carburetors suck because they're complicated and they're full of itty bitty little pieces. So here is the parts diagram of a more complicated carburetor. And I don't want to mess with it. Look at this thing. If that's your jam, you're the man or lady, but I'm not messing with it. So this is a sideways example of that carburetor and how it works, and it's like super. Or this is kind of not a great. What I want you to do is imagine that this is the bottom over here. So almost if we rotated this entire picture 90 degrees. How about that? How about we clean this up? No, like this. Clean this up, and I'll draw it more better. Alright, so on the bottom of the carburetor, we're going to have the float bowl. Boop. Now, fresh gasoline gets poured into here. We've got a little valve, though, that closes. We call this the float valve. It's attached to you wouldn't believe it, a float, right? So as the gasoline gets used, the float drops. That opens this valve, allows more fuel into the float bowl, right? And then let's cap this float bowl off here. So we'll do, that part will be black, and then we'll do the next little bit, and let's pick a different color. Let's do red. Okay, so float bowl down here. We've got a little valve. When the float drops, because there's no gasoline, that allows more gasoline to be pushed in. And as long as this guy has fuel in it, the engine will run. The problem with this, guys, is that gasoline over time turns into jelly. And I'm not even making that up. Let's pull up the YouTube over. Let's get a good picture of some old gas. No, I want pictures. Show it to me. It's green. No, not gas. Oh, you freaking idiots. Bad gas. Oh, that's amazing. That is not at all. Okay. Oh, Lord. Here is a great example. Fresh gasoline on the right should be clear or golden color like honey. And as it sits, it literally turns green here on the left. So what I normally like to do at this point is go into the shop and show you. There was an old motorcycle in the shop when I first got there, and it had its carburetor sitting forever. And if you take the carburetor apart, it is stained green. Gasoline turns green. So a sign that you have bad gas is that there's green debris, and then the smell is very unique to bad gas. And then the problem, the reason that we care, is it becomes a very thick putty, which Google did not help me. But why do we care if it becomes solid? And it's not solid. It's very much like jello. That's a good word for it. But carb jet. So this is what it has to get pulled through. And this guy, oh, check this out. Here's a carburetor. Yeah, upside down. Oh, show it to me. Nope. Here we go. Very cool. So these little jets live in the bottom of the carburetor, and you can see how small that is. So if this fuel that's been sitting down here is starting to solidify, it gets pulled up in that jet and clogs it. And this is why that weed eater, that lawnmower, don't run. You put the lawnmower away in August or November last year, and you left the fuel in it, right? You just let it sit, and then now that it's April, you go to start it again, and it won't start. And the reason is a small amount of that fuel got pulled into the jet. All you have to do is take it out, soak that jet in acetone, clean it out with a wire, and then ta-da, it'll run again. So let's keep moving with our drawing here. So in the bottom we have somewhere to store some fuel. We've got two jets, so just think of straws. Had I drawn it a second ago, we've got two straws, the primary and the idle. So the idle one is very, very small, little bitty, just to keep the engine idling, and then of course the bigger one allows for much more when the throttle opens. So we've got two butterflies, and you guys know what I mean when I say butterflies. The throttle body in any car is a butterfly. Here in this diagram, this is a butterfly, and this is one as well. Don't have a better picture here, but you guys know what a throttle body looks like. So here at the front of the carburetor, we're gonna have a butterfly. Let's do the butterflies. And what's a pretty color for a butterfly? Yellow. Do it like a yellow. And you know he's a circle with a. That way he can open and close. And we've got one over here. So you've heard of pull the choke on an older vehicle, or maybe your lawnmower has a choke on it, or your old four-wheeler, and that is normally this front one. So if air is being pulled, vacuum this way, then the front one is normally the choke. And the idea is that if I restrict the air, less air, we get more fuel. Does that make sense? Because we're talking about air and fuel. And when an engine is cold, you need more fuel to get it going. If you notice, we get in any one of your vehicles outside in the parking lot, when you first start it, the RPM is very high. And a part of that is it's running super rich. And then after 3 or 4 minutes, when the engine warms up, the RPM comes down, and that's it letting it go back to normal air to fuel ratio. Or if you wanted to play with the scan tool and hook it up to the O2 sensors, you could watch them all day. When you start it, it'll be super rich, so like 12 to 1 instead of 14.7 to 1, and then as you let it run, it'll go further and further and further to 14.7 to 1. So if you ever hear that word choke, that's what that means. You only use it to get the engine started. Once the engine is started, you open it up and just get it out of the way. And the other one would be your throttle. So every time you twist the throttle, it'll open this more. So if I open this more, I give more air. If I give more air moving quickly, it'll pull more fuel. Right? So in a very simple carburetor, like the one in this, over here, this guy, and the one in your lawnmower, and the one in, actually my boy's dirt bike looks just like this one. The float bowl on the bottom, right? So this would be it vertically. Then we've got air coming through here in the center. So this is it turned sideways. We've got these two jets, right? So this is actually a pretty cool little guy right here. Oh, yep, dirt bike called it. So carburetors are, and a simple carburetor is not bad. A super complicated carburetor, though, I just don't want to mess with. But I want you guys to be able to clean them. And the other thing too is these bigger carburetors have idle screws and air to fuel ratio screws and adjustments all over them. And that 4-barrel, where's that 4-barrel I had? This dude over, where is he? You, sir, have way too many adjustments, and that's another big pain. The simple one, like my son's dirt bike, only has one adjustment for idle. So there's nothing else to adjust. It's such a small engine and such a small carburetor, so simple that it just runs. I go to kick it, it'll start right now. Part of it is I don't leave fuel in it. So if you guys want, that's another tip there for you. When you put the lawnmower away in August, there's a drain on here. That's what this screw is right here. Or cut the fuel line off. Not cut the fuel line off. Cut the fuel line. No, don't cut. Let me try to say this. Cut the fuel. Close the fuel line. Whatever you gotta do. And then let the engine run until it runs out of fuel. And then you know there's no fuel in this. So that's what we do around here because I hate cleaning carburetors. This guy over here, the problem is every time the weather changes, you got to get out here and adjust something. So when it's cold, the air to fuel ratio is different, right? Because air is more dense. Has nothing to do with how much air is being pulled. The engine didn't change, but the mass of that air changed because it's denser. So in the winter, if we had actual seasons, you'd be out there readjusting your carburetor, and then when it warmed up, you'd change it, and you'd be out there with a screwdriver, and then when it rained, you'd be out there again. So this is the downside being you got to adjust it all the time. Whereas if it's fuel injected, the computer makes those adjustments for you on the fly all day long. And then the other thing is that this is another big RPM limiter, right? So on my terrible drawing here, I can only get as much fuel through here as these jets will allow. So at 5,000 RPM, maybe the engine can get more air. Maybe the engine could keep revving, but I cannot keep up with the fuel. And we said that it's more dangerous for an engine to run lean, right? Do you remember me saying that? So what this example means is the engine is revving and revving and revving and revving, and my fuel supply is not able to keep up, and then the engine explodes. So if we do any amount of looking at dyno fails, watch this, will take me no time. YouTube, dyno fails. Dyno fails. Compilation. Outside of them coming off of the dyno, oh look at these geniuses here. Outside of the car coming off the dyno, which does happen sometimes. Let's see if I can get some audio here. The engines explode. And anytime we go to a dyno, we're usually adjusting the air to fuel ratio, and that's somebody's job, right? That's the tuner's job. So if he's not keeping it rich enough, he's not keeping that, we call it fat enough, and it leans out, the engine will explode. Here's my Subaru. Oh, that's a Lancer. Nope, my bad. Oh, no! Oh, you're fired. Oh. You're done, sir. Alright, show us the engine blowing up. There we go. Are you gonna blow up? Oh, everybody's coming off the dynos. God, that must be the most scary thing. Whoa. Look at that turbo. Look at this big turbo. What in the world kind of engine? Boom! We ran lean and it detonated, like Mr. C said. Okay, enough of that. Maybe that'll be homework, you guys. So, I've talked enough about carburetors. Let's talk about the fuel injectors. Normally, my philosophy is it's either working or it's not working. The fuel injectors aren't as small, their little nozzles aren't as small as jets in a carburetor, and it's never really been my experience that it will get one that is clogged. When I worked at the motorcycle shop, we would have four-wheelers and dirt bikes that, like the lawnmower, sat up with fuel in them for a long time. And then the fuel injector wouldn't spray at all, so we would take it out and soak it, and then it would work. A lot of people talk about spray pattern, and that's actually what this video is. That's not why I loaded it up. I've never had one where the injector was spraying in a bad way. It's normally either spraying or not spraying. And what we've always done, where like if I needed to test one, we could take the fuel rail off and then put the injectors back in the fuel rail, fill the fuel rail up with brake parts cleaner, put shop air to it, right? So now we have some sort of spray under pressure, and then the injectors they only have 2 pins on them. So if you jump power and ground, it'll open the injector. So we used to have a little, well, I made it because I like to run wires, a little jig where it had 2 alligator clamps, put it on a battery, and then it had 2 pins from a switch. We just put it in the injector, one pin, the other pin, flip the switch on and off, and then watch this thing spray. And then you knew, so like in this is what it looks like when they spray. You either see them spraying or not. So he was talking about after cleaning them or something. I'm not I didn't really watch it. I just wanted you guys to see what it looked like when they're spraying. So, as far as injectors, they will fail, and so this is in the page 12 is part of why I've never really had one with any of these. Mine are either good right here, spraying, or not spraying. So if it's not spraying, you have this option where maybe we try to sell them cleaning it if we know it's sat up with fuel in it for a long time. But even after you clean it, it may not guarantee it's spraying correctly. Or what if you guarantee, hey, let me try to clean it, and they say yes, and then you charge them an hour to clean it, and it's not because it's clogged, it's because it's failed. So um, my experience has always been, dude, let me price you out a new injector. And when they fail, it's normally one at a time. So it's not like, oh man, you need all 6 injectors. No, no, no. You need the one. It's either working or it's not working. And when we talk about diag at the end, I'll talk a little bit more about that. Um, Service down here, page 12, right? Page 12, following along. So all the little gaskets and a little bit in a carburetor, and then itty bitty little jets. So those things. Please remember that these injectors have 2 O-rings. So the way that the injector is held against the intake manifold or in the engine, there's no bolts on it. You note that there are no bolts or screws. This end, the fat end, goes down into the intake manifold, and then the fuel rail goes on top, and you snap it down, and the fuel rail gets bolted down. So I say that it's important because the fuel rail will be, if it's a V6, so it'll be at least 3 injectors, or if it's inline 4, it'll be at least 4 injectors, and you want to get the fuel rail down flat, but we all know that's impossible. So you do this little seesaw motion with your hands, and we do not want one of these O-rings to get torn. If the O-ring tears, it's going to spray fuel all over the engine. It's not really going to ignite, it's not really going to explode, but God forbid that you don't notice it, and then the customer drives home and they smell the fuel. They go looking for it and they find that you're spraying, you touched it last, and now we're spraying raw fuel all over the engine, and in their brain, it's a disaster. In their brain, they go straight to the movies where the gas tank explodes and the whole car blows up. So I say that this is so simple. Just every time you ever put injectors back in, put a little wheel bearing grease, some kind of silicone grease, some kind of spray, put some kind of lubricant on these O-rings, okay? And then let's move on to the intake here. Intake is a very, very simple thing, and so, yeah, you guys are almost done for today. None of these are ever really going to break, except, you see all the waffling, that's what I call it, all the ribs in this rubber here, those are going to tear. And I'll show you in a second how we're going to diagnose that. But for the intake system, we're going to have a manifold. So just like the fuel rail is a steady supply of fuel whenever you need it, the manifold serves as a supply of fresh that has been cleaned, been put through an air cleaner, maybe under some vacuum or under some pressure, and very close to the intake valves, right? And then from the manifold, we're also going to have a bunch of tubing. We need vacuum lines. So here we see some vacuum lines. We need vacuum lines for all kind of stuff now. So there'll be a bunch of those. A lot of manufacturers put these extra little tanks. So this tank, that tank, this tank, just somewhere in it, and it serves as another reservoir. And then of course you've got your filter even further down. So we're going to skip what the text say. This is cool. I have a video about that. We'll come back to that in a moment. How do you know that the air filter is dirty? And it has nothing to do with color, guys. If we haven't talked about this before, but I'm almost positive we did, it's whether or not you can see air through it. We don't care what color it is. With the mass airflow sensors, there's a little bit of oil on this reed. Do not touch it with your hand because there's oil on your hands. So they make cleaner. This is a popular GM problem, that the mass airflow meter will become dirty, and then you have to clean it, and then you need to re-lubricate it. And if it was me, guys, I'm buying the GM stuff for that. It can't be that expensive. I don't want to have to put a new mass airflow meter in because I ruined it because I used the wrong stuff on it. So when I worked at Toyota for a long time, we didn't ever clean them, but we didn't ever really have problems with them getting dirty. That wasn't a problem with Toyota. Ours would fail just like anybody else's would fail. They're not bulletproof, but we didn't have a reed that got dirty in the same way. And let's please remember, like this, the Miata outside, that when we do this, have we changed the amount of air and the density of the air getting into the engine now? Absolutely, we have. Did we notify the engine computer, hey man, we added more air, you should probably add more fuel? No, we did not. Does the engine compensate? Well, we have O2 sensors, so it ought to. What happens if we get to the end of the factory specifications and the computer says we don't adjust any further than that? So I always like to point that out. Your first modification on your car, because that's what we're here for, right? Uh, Engine performance should not be intake and exhaust. It should be some way to modify the computer. So on my car, the very first upgrade is a cob access port, and what that does is allow me to reflash the computer to adjust. So as I start adding cold air intake and a bigger intercooler and a big fat exhaust and a big downpipe and blah 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 blah, all that cool stuff that you guys want to install, if you have the ability every time you change something to then tell the computer, hey man, I added more air, add more fuel, then you'll never be in a situation where you lean out, because when you lean out, it explodes, right? And please, no Home Depot kits. I wish I had never seen this, but I have had a Civic that the guy, he bought an eBay cold air intake kit, and it came with dryer hose. I'm not even making this up, so it happens. With the ribbing, so here's a great example. The only reason you can see this tear is because he's pushing against it. But when it's in the car, when it is just regular, where's the good? Who's got some ribbing? You're smooth. Those guys that we had up here on that other page. These guys, when he's just in the car, you're not going to be able to see a cut or a tear, okay? It's only because he has pulled it with his thumb. So here in a minute we're going to talk about misfires, and then I'm going to tell you how you're going to find that, and it's really easy actually, so don't worry. Please don't be that guy that puts masking tape or duct tape over this. Like, you can spend $15 on a new hose, Lord almighty. And then review quiz, I want you guys to go through it, and then of course here's all your answers down at the bottom. So I took a couple of videos of the intake systems on these cars outside. I'm going to patch those in, and then we'll talk about diagnostic. Alright, so out here on the Miata we've got the cold air intake, and then this mass airflow that they've kind of plumbed into it. Some vacuum lines coming off of it, and a throttle position sensor there, intake manifold, and a PCV. So I'm going to try to point out the PCV to you. Here's wife's Highlander, airbox, air filter, mass airflow. We see one of those tanks I was talking about, my terrible hand camera, coordination, and some vacuum lines to the PCV, which is, there's my throttle position sensor, and then here is PCV, which we'll get into more depth next week, but it's going to be part of the intake system technically. And then Subaru, of course, is a terrible, this flat 4, so we've got some intake to over here. That's a boost to the intercooler, whereas there's my intercooler, and then the front web is the intake manifold. I'm not sure if we can see anything on this side. Where's my I'm looking for the PCV. So that's intake for the brake booster, which I should have pointed out on the other cars. And then over here, one of these is PCV to my 2. I have 2 heads because it's a flat 4. Alright guys, I like this video about intake runners, variable length intake runners. We haven't talked about it yet. So the idea is that if the air has to travel a further distance in a small area, it will increase velocity. So on your muscle car you had a high-rise intake, or they call them velocity stacks, and it made way more performance, but it sacrificed idle and reliability. So here, check this out, we have 3 different paths the air could take through this intake manifold. So most of our intake manifolds that are plastic now, that look like this, so the one on my Subaru and the one on Mama's Highlander, and that Mazda certainly didn't have it, it's a little bit older, have this sort of setup. So we can have the best of, in this one, 3 different setups that can all change on the fly, computer controlled. There's kind of a theme here. We go from the old technology to the new technology. So this is not a serviceable part on Toyotas. I was told that at Honda you can replace just this guy in the middle, which this is a Honda diagram here. Yeah, I was told you can replace this part. But on Toyota, if it fails, you have to get a new intake manifold, which kind of sucks. So one thing to be mindful of is that even the intake manifold now is controlled by the computer. And what I want you guys to do is, so go to YouTube. This is going to be your homework. So like last week we had 2 questions. So this week is going to be, I'm going to have a question for you when we speak. And I want you to have watched this video. So go to YouTube and go to type in variable length intake runners, and Engineering Explained. This dude does a great job, variable intake manifolds and intake timing or tuning. So check this out, because if you want to learn about performance, it's not long, it's only 4 minutes long, 5 minutes long. If you want to learn about performance, there's a lot of information in there. So I'm not going to watch it with you because we need a question for this week, but that's something I want you guys to check out. So we've gone over a lot today. We're nearly done. My last question, so 2 questions, is going to be the difference between VTEC and VBTI. So when I was a young tech, I thought the difference between VTEC and VBTI was who branded it. I thought VTEC meant it had to be Honda, and VBTI meant it had to be Toyota, and then VTI, VIV, LMNOP had to be Mazda, and that's not quite how it works. They're all variable valve timing events, which is awesome. So another layer of something that we're controlling with the computer. And so when I call you, or you call me later this week, I want you to tell me why in the world we would want to control the valve timing. So when you go to look this up, you need a video on valve timing. CNET has a great video that I normally show in class, but my lecture's getting to be, how long are we at already? Yeah, we're at 15 minutes and I want to keep it to an hour, so I'm going to shorten it. If you guys have questions, this is stuff you need to be writing down. I would love to talk to you individually about this at length, but I'm trying to keep this video to an hour. So we're going to work through a couple check engine light scenarios real quick. And I'm going to just sketch them out terribly because that's what we do here. So let's talk about a misfire. We've got P0301 or P0300. So give me some regular color here. I've got my 4 cylinders. Let's just use the 4 cylinder. Boop, 2, 3, and 4. Now P0304, I'm sorry, P0300, P0300. So when you go to check the scan tool, this is what it's going to say, P0300. And that's all it says. It doesn't give you any information that. But I happen to have off the top of my head, this means multiple random misfire. So that means in any sort of randomness, however, I have seen multiple cylinders misfiring, which is different from, we'll do just a generic P0301, which means miss on cylinder 1. And then you can imagine P0302 would be miss on cylinder 2, P0303 would be miss on cylinder 3. So how and why it knows it's misfiring is a little more complicated than what we need. For right now, for where we're at, just understand that you will get this code, and really the point of this is I want you to see how I think the best way to diagnose would be. So on this one, P0300, we need to think about all the things that could cause the entire engine to misfire, okay? Not just the things that would cause an individual cylinder misfire. So air, fuel, and spark. What could we do so that the engine wouldn't get the right amount of air? Well, nobody's going to like clog up the intake. However, the mass airflow meter or the MAP sensor, right? Whoever's telling the computer this is how much air we're using, if it's lying, then we could have some mistakes. If my fuel delivery, so there could be the fuel pump, if there's a filter that's clogged, is inadequate, so maybe we're not getting enough, then that could cause multiple, right? All the cylinders equally. And finally, a vacuum leak. So now we have too much air, more than what we wanted, right? And especially if we get a vacuum leak past this mass airflow meter, so that we're getting air that the computer doesn't know about, that would affect the entire engine. And we always have to put harness and ECU, so whatever wires go in between and whatever computer's controlling this. And those are always the last two on any check engine light ever. Over here, let's do the same thing, but let's do what would affect just this cylinder. So for air, there's nothing I can think of that would affect just that cylinder unless it had severe compression problems, and we're going to talk about that probably more in week 4, when we spend most of the day talking about diagnosing things. So I need to make myself a little note here. Week 4 compression. Okay. So what about fuel? So would that be a fuel pump? No, because that would be all the cylinders. Would that be a fuel filter? No, but it could be a fuel injector. Let's use spark. If it had a distributor, that wouldn't be a distributor because that would affect all the cylinders. However, we know this has a coil for just that cylinder, and it has a spark plug for just that cylinder. So it could be those. And outside of low compression, I can't really think of anything else, so we're gonna always put harness and ECU because technically that could fail. It's just in reality it's very unlikely. Alright, so if I have PO300, I don't care what the book says, I'm gonna start with what is the easiest thing to check, and the easiest is always spark. I know I didn't even put spark in here, but you know how many bolts I have to take out? There's one bolt hole in the coil and then the spark plug itself. So I'm going to pull it out and just make sure I have spark on any cylinder, whatever one is easiest to get to, just to cross that off the list, because air, fuel, and spark, right? You follow me? It's nice and easy. It's right there on top. So once I know that that's good, I probably want to see that I have good fuel. So when I showed you the little snippet of the Mazda 3, I showed you the fuel lines with coming from the rail with a quick disconnect. All you have to do is go quick disconnect, and then go to sales and get one of those clear plastic cups, and either you hold it and have somebody else turn the key. You don't even have to turn the engine on. Just turn the key to run, because at that point the fuel pump is supposed to prime, and it should start spraying fuel. If you get no fuel, okay, we know it's a fuel problem. If it fills the cup up in a second, you know you have great fuel. If you are not sure, at this point we will go get a fuel pressure gauge. But the first step is, let's at least look at the fuel, because if it looks good, I'm not worried about it. Oh, I'm not getting any fuel. Ta-da, I know exactly which way to go. So let's cross fuel delivery off. I want pencil. So let's cross fuel delivery off. We looked at you. Next, in my opinion, I'm thinking I want to make sure the mass airflow or the map is doing what it's supposed to. So I already have the scan tool hooked up to the car. That's how I found out I had a PO300 to start with. So we'll go look at the live data, and this is another thing that we will do hands-on, because I want you guys to have practice with the scan tool. So when we get back in the classroom, we're going to go play with the scan tool. But this is just, you just hook it up live data with the engine running and see what it says. And if you don't know if that's a good number, compare it to another car, because at Toyota we have 472 Camrys outside, or at Ford you have 372 F-150s, or the book has this information. So it should say at idle, you expect the mass airflow to read whatever. And at 3,000 RPM, we expect the mass airflow to read whatever. And then you can compare it. Ta-da! So you're never going to get away from reading. We're always going to be reading. But I'm going to show you this on purpose, because this may not be the order of operations that Ford thinks is the fastest. It just happens to be how I think. After that, a vacuum leak. So in order to test for a vacuum leak, you're going to walk around the entire intake, all that rubber tubing, with some carburetor cleaner, something flammable, and you're going to spray a little bit at a time, little pss, pss, pss. Not a whole lot. That stuff is highly volatile, and if you spray half a can in there, it might blow the engine up. But just a little. And if it gets pulled, it's a vacuum leak. If it gets pulled into the intake, it's going to make the engine act funny. Most of the time, it causes the engine to rev up. You've just given it more fuel. It's going to rev up. Sometimes, it'll make the engine want to stall. So, what you're listening for is you've got the engine warmed up, it's at a steady idle, a steady RPM, and you walk around a little bit at a time and you go spray, 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 and you listen. And if nothing happens, you move to the next little section, spray, spray, spray. When you hear, whoom, it rev up, you go, I'm getting close. And then you, with the needle in your spray, the little straw, you can start to hone in. Oh, it's right here. So in my brain, I'm thinking, is it an intake manifold leak? So let's check, because there's gaskets there. Where the throttle body meets the intake manifold, there's a gasket. Let's spray right there. All that rubber hose, let's spray there. Where the mass airflow goes in, let's spray there. If we get past the mass airflow, further than the mass airflow, we don't have to worry about it, because if there was a vacuum leak, the MAF sensor would still pick it up. So that's not going to cause this check engine light, even if it's there. Hope that makes sense. If I don't find anything there, it's time to start thinking harness and ECU. In the repair manual, ECU will always be the last thing, because you can't test a computer. All you can do is replace it with another one. So in my brain, I'm going in this direction. We went from easiest to most difficult, hoping that we will find something quickly. Also, it's my experience that if we have a random multiple, it's usually fuel or vacuum leak. It's 13 years of doing this. So, but if we get 301, this is my favorite part, and this exemplifies having a simple. Sometimes somebody will say something to you, and you just go, "Man, that's a lot simpler." Yesterday, my neighbor's motorcycle wasn't. He got it running, and then he drove it around the block and he burnt some wires up. It's like a 1987 VT 1100. I have no idea what these wires are for. So my other neighbor is a mechanic, and I are over there looking at this dude's motorcycle. And I found the wires, and I'm putting them back together, and I actually found the book with a wiring diagram, and it's 3 yellow wires, and they all go together. And why are they all the same color, Honda? That's terrible. Why would you do this to me? So I'm not sure I'm getting exactly what I need, and the schematic that I have is old, and it's not very accurate. So I've got it pinpointed it's these 3, but I'm not sure which ones to connect. And I'm kind of testing it, and my other mechanic neighbor was like, "Bro, there's a fuse in it. Just wrap those wires together, hit the switch, and see if it works. If it works, cool, you got it. If it doesn't work, we put a fuse in line, it'll just pop the fuse. Like, nothing to worry about." Phone again, sorry. At which point it was like, yeah, that's a lot simpler. Why don't we just do that? So for this one, we're gonna keep it nice and simple. If it's missing on cylinder 1, so cylinder 1, it is gonna be the spark plug, it's gonna be a coil, or it's gonna be fuel injector. Like, that's it. It could be low compression if the engine's a bit damaged, but it's not gonna be. So what you can do is, we talked about how difficult it is to swap a spark plug and a coil, right? One 10mm bolt for the coil and take the spark plug out. So if it's me, I'm taking this spark plug and I'm moving it over here. Spark plug is, I can't draw with the mouse. Spark plug is going in cylinder 2. Coil is going in cylinder 3. Now normally, if it's a 4-cylinder or a V6, 3 of the cylinders are really easy to get to. So that's why I did it this way. And then my coil is going this way. Boop. Now, I'm going to go back in the car, clear the check engine light, let it run until the check engine light comes back on again. And if this has now become a P0302, cylinder misfire 2, I just proved that that spark plug was bad. If it becomes a P0303, we know it's the coil. We just proved that that was bad. If it stays cylinder 1, we know it wasn't the spark plug. So it's not it's not spark plug, and it's not the coil. Also, how much time did this take? Maybe 5-10 minutes, right? So we're getting 1 hour diag and we're making time. Now, and my next thought is the fuel injector. And the fuel injector can be difficult because I said you can't just pull one out. So if this is a V6 and this is the front of my engine, there's a fuel rail with an injector on each one of these. So I can't just quickly take one out. So what I'm going to do is take those and go ahead and swap these 2, or whichever ones are easiest, as this is step 2 now, for my fuel injector. And I'm hoping that when I go clear the light, that's supposed to be an F, not a P. Terrible with the mouse. Go clear the light, let it run, check engine light comes back on. I'm hoping it now becomes a P0302 misfire wherever I just put this fuel injector. And then I just proved it was the fuel injector. If it's none of those things, we need to then check compression, which we're going to talk about more later. And that's really a lot of engine repair. That's the mechanical side of it. But that'll be an old tired engine. That's not going to be on anything that we have to deal with really. Or it'd be harness and ECU, and there's really, it's not going to be either of those. It could be the ECU, as anything could always be the ECU, but the percentage of computers that fail is so small. And then harness is funny because we include it in every check engine light. But let's be honest, if I cut the wires, so we've got, let's pretend this is my fuel injector right here, okay? Fuel injector on this one, and we've got 3 wires leaving the computer to tell this fuel injector to come on, okay? Green for ground, red for hot, and we'll have like blue for signal, okay? If I cut any of them, then I get a separate check engine light for fuel injector cylinder 3, circuit high, circuit low, circuit something. So what's nice is we have so many codes now that they've become so specific that in these kind of situations, so 10 years ago, 15 years ago, you may have had to consider the harness. But on what we work on now, if we cut one of these wires or these wires get melted together, we will have a separate code for that, which makes this really cool, I think. So this is part of my philosophy again on how to diagnose. Just put them in order of possible causes, knock them out. The easiest one first. I don't care what the book says. I'm doing it this way. I will consult the book because their list of possible causes may have something I didn't think of. And when you guys are first starting out, you should probably go in order because it's easier to take notes that way. So on the back of the RO, after I swapped this spark plug and this coil, I'm going to write down. I swapped spark plug and coil to 2 and 3, cleared check engine light, came back PO301. Then pulled the fuel rail, swapped injectors, came back with a PO302. I priced out an injector, sort of thing. So that way later, if anybody asks you what you did, you've got it. But let me look at my thing over here. So that's about it for today. I want to wrap this up now. So I went over a lot. If you guys have questions, I'm hoping you do. I'm expecting you to call me Friday. I think Friday should be fair, between 5 and 6. Or if you guys want to take a lunch in the middle of the day, just for 5 minutes. I'm going to ask you my 2 questions and then answer any questions you have. Please be getting on this homework. I do not want to be chasing you guys over your CDX. You have 3 weeks now to get it done, and this is a big one. Engine performance is complicated, but in order for us to be masters of what we do, we've got to nail this. So I'm going to wrap it up with that, and I will talk to you guys later.